Boo. I gotcha. Just kidding. Hey, here we go. Section 3, moving on, going beyond the proving triangles congruent. So we just did SSS, ASA, side angle side, SAS, yes, HL, and we did the angle side postulate. So those 5 shortcuts to prove triangles congruent. Now we're going to go beyond that, and yes, that means the proofs are going to get much, much bigger. Oh yeah, so sit down if you're not already. But here in this video, we're going to talk very quickly about the basic properties of circles and how they can be applied in geometry. So let's dive into this and let's do it. Here we go. So guys, some basics about circles is this, and you can write down really whatever you want, but I would tell you everything that you hear as a definition or as a picture or something, you should write down in your notes. There's no doubt. There's no foldable for this. It's just some basics of circles, like I said in the essential question. But here we go. Let's recall what an actual circle is, because sometimes I know you all know what circles look like, but here's kind of the definition, if you will, of what circles are. If you see over here where I have this segment BA, BA, and it says the length of it is 5.26. Well, if I put a dot right there where A is, wonderful, that dot is a distance of 5.26 away from B. If I take this thing though and I move it over here, and as I move it, as you see, if I kind of keep putting dots, dot there, dot, all these dots, so all these little dots, you see them all? Dot, 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 dot. If every one of these dots is exactly the same distance, 5.26 centimeters, away from this particular fixed point right there, well, what that's creating is a set of points that's very unique in that they're all the same distance from one other point. Well, if I just keep going with that and put a whole bunch of, whoa, check it out. If this thing keeps on going and keeps putting points at 5.26 centimeters away from the center, this point B, this fixed point, what it's creating, you can see it, what it's creating is nothing more than just a wonderful little circle. So, what then is a circle? A circle by definition is a set of infinite number of points, a set of points that are all equidistant from one particular point. So I'll stop this right now. So there's your wonderful little circle. It's a beautiful circle, but that's exactly what a circle is. Now, here is question number 1. Do you know? We're going to find out. This thing right here, this thing that goes from the center to the outer part, that has a special name. You know what it's called? You got it. It's called the radius. So you should write that down, at least an example. Actually, you know what? Let's cut over to this side. So here we go. So I will do this. So from the let's just draw this. So the center of the circle is C. From that point to that point right there, boom, right there that I just drew. That thing right there, I don't know why it doesn't label it, but here we go. I'm sure I can label it. We'll just say show label. There you go. So that's point D. So CD happens to be a radius. Well, here's another question. What is this thing that would go from like side of the rim of the circle way over here to the side like that? You can see as it changes colors, it just touches. So a segment that has its endpoints on the circle. Do you know what that thing's called? Oh, did you know? I didn't know if you knew or not. It's actually called a chord. So I'll label that one. I'll label this one. So this is E and F. So segment EF is an example of a chord, not a car, not a Honda Accord. It's a chord, C-H-O-R-D. So that's a chord. And again, you got the definition. Go back and listen to it. Oh, you know what I forgot to tell you? This point right here, the point in the middle, that's an extremely important point. This whole entire thing right here is actually would be called circle. There's a name for it, just like we have angle or segment or triangle. This will be called circle C. So you use the middle point, guys, to actually name your circle. So that is circle C. So we got chord, we got center, we got this thing right here called the radius. Here's another one that you may recall. What if I take a segment from one side of the circle, one part of the rim of the circle, like that, and I take and go right through the center, but I pull it the whole way over here to the other side. So it goes through the center of the circle, but it goes across the whole way and touches. So it's a segment that has its endpoints on the circle. Boop. What is that thing called right there? You got it. That thing right there is called a diameter. So I'll make it point G and point H. So GH, from G the whole way over to H, that is called a diameter. Okay? Now notice diameters don't have to go left to right, horizontally or vertically. It's anywhere. Radius can go anywhere. In fact, what I've just created is this. A diameter actually has 2 radii. There's your plural of radius, R-A-D-I-I. So from C to H, that's a radius. From C to G, that's a radius. From C to D, that's a radius. So they're all radii of that circle. Beautiful. We got all kinds of things going on. This is neat. That's really about the basics of the definitions that I want you to know. We got chord, diameter, center of the circle. You got the definition of circle. You got radius. The next thing I want to talk about, though, is this. Let me transition to a different circle. Let's say that we have one radius in a circle. And we'll say the distance is 4.5, as it says right here. I mean, I can make it smaller. I can make it 2. I can make it, really big. But let's say it's 4.5. Well, here's a question. If I drew another radius in the same circle, so I go from the center and I draw it, we'll go this way. Doesn't matter. So it labeled that point for me as point G. Beautiful. My question to you is, what do you think we could say about the distance from A to G? You got it. The distance from A to G would be exactly the same distance from A to B. So let me show you. I'll just click on this and I'll go length. So it looks a little different, but it doesn't matter. Notice this. Oh, look at that. So segment AG is the same exact length, distance, whatever, as segment AB. And it certainly makes sense. You know what? What if I drew another radius right here? We'll call it radius HA. So HA. Wonder what that distance is. Well, I'll show you. Oh, look, it's 4.5. So I can make this circle as big as I want. Look at this. Whew, doesn't matter how big I make the circle. Whew, 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 whew. So if I stop right there, notice this. All the radii are exactly the same. It doesn't matter how small. Oh, look at the cute little circle. Oh, it's a cute little thing. Well, look at it. All the radii are still the same. What am I doing all this for? Well, one, it's kind of cute to talk like that. It's a cute little thing. But that is leading to a theorem for you guys. And here it is. It is theorem 19, and it says all radii of a circle are congruent. One of the shortest theorems that you're going to have in this entire year, next to the one that says vertical angles are congruent. But you will use this in 2-column proofs. In fact, I'm going to show you one right now. So what you're probably going to want to do is pause the video and copy this bad boy down. But I'm going to keep talking. So you can pause it and then catch up, of course. But here we go. So you're given circle well. And by the way that I drew it in the given information is how you're going to probably see it in your book. They're going to put this little circle symbol with a little dot in the middle. Just like we have a triangle symbol, we have an angle symbol, we got segment symbols, we got ray symbols, we got them all. They have a circle symbol, and O is the center of the circle. And we're given BC, that guy, is congruent to FD, that guy right there. And we're proving the 2 triangles. That would be this guy right here. So BOA, whoa, that guy. And this guy congruent, FOA. So that guy. That guy right there. Nice. So, let me do that again. It's ugly. Wow. Cool. Okay. So here's our only options, though. Remember, we got HL, we got side, angle, side, we got angle, side, angle, we got side, 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 and we got angle, angle, side. Remember, no donkey theorem, so that doesn't work. So here's what I'm given. If I look at the picture, ooh, man. Well, I don't really have anything given to me. I don't see anything here that's going to indicate to me perpendicularity, right angles, complementary, nothing. So honestly, I would probably mentally rule that one out right there. Even though, yes, I know this looks like a right angle, we don't know that. Could be, but we don't know it. So I'm going to rule that one out. Well, my only options are these guys then. Well, let's do it. So the first thing I think I see is that, well, if I label this angle 1 and I label this angle 2, I can put that little tick mark on there and that little tick mark and put in my proof angle 1 and angle 2 are congruent. Why, Mater? Because vertical angles are congruent. Weird, I just talked about that one. That's the shortest, one of the shortest theorems that you're ever going to have. Ooh, which reminds me of the next theorem. Wait a minute. I have circle O, and in circle O, what is this thing right here from O to A? Well, yes, my ladies and gentlemen, that is a radius. And so is O to F, or sorry, O to E. So O to E, OD, that guy, E to O, and OA are congruent to each other because they are radii. So I'll put a tick mark there. I'll put a tick mark there because I can say AO is congruent to OE. What is my reason? Because it looks like it? Because I want them to be? No, my ladies and gentlemen, it is this. All radii, aye, Captain, of a circle are congruent. That is your reason right there. All radii of a circle are congruent. Wait a minute. Let me take stock in where I am with my proving the triangle is congruent. I have a side, I have an angle. So I'd do this. I'd roll that one out. I certainly am not doing two sides. And I have a side and an angle. Well, I can't rule any of these out yet because that's kind of the way it goes. Now, how can I finish it? Can I get another angle? Ooh, or can I get another side? Well, here's my proposal to you. Take a look. If we know from O to A and O to E are the same distance, which they are because they're radii, what about from O way over here to C? Yeah, I know, Ocean City, I got you. Nice, OC. That distance O to C, oh, wait a minute. That's another radius. Oh, beautiful. So OC, I actually want to put this right here. OC is congruent to this distance here. I'll make a different color. I'm running out of colors. I'll use red. Not really that much of a difference. I'll use yellow. So from here, whoa, it's kind of hard to see probably on your screen, sorry. But that distance right there is exactly the same too. So O to D, you can't even read that. Come on, Mater. O to D and O to C. What a colorful proof this is. So the reason is exactly the same. All radii of a circle are congruent. Well, where does that lead to? Well, what I have is since OC, since that guy, OC is congruent to OD, and I have given information that this little segment here is congruent to this little segment, oh yeah, I can conclude that this little guy is congruent to that little guy through our simple little thing called subtraction. So step number 4 would say, O, well, I can't even see what it says anymore. I guess it's a B. OB, or BO, ooh, stinky BO, and FO, fo, fee, fi, fo, fum, you got some BO. So step 4, what is that? Oh, I just told you, subtraction. Subtraction property, and that's beautiful. Why is that cool? Because now we have an angle, we have our side right here, and we were actually, we got our second side right there. Whoa, that looks like a bad word. But hey, we got two sides and we got an angle, and the nice thing about it is the angle is included. So step number 5 is what I'm trying to prove. Triangle boa constrictor congruent to fo, and my reason is side, angle, side. And my numbers, you can see it now, it's kind of easy. It's step 3 is where I got one side. That would be this one, the purple one, OA and OE. My angle is in step 2. And my last side is in step 4. Ladies and gentlemen, there you go. So you use a simple little feature of circles to prove triangles congruent. And yes, we're going to use this to go beyond as well. So there you go. See you in class later.